Hey there, Trig fans. We are almost done with matrices. We gone through this little bit of a journey for the last 8 or so lessons about what a matrix is, how to arrange it, some of the things in it that are called elements, the order of it, what happens when you add matrices, what happens when you subtract, what happens when you multiply matrices. So we are kind of in the middle of this, and today is one of those lessons where we start to use matrices to solve things in algebra called equations. So one of the biggest pieces in all of algebra 1, 2, and 3 is that variables or algebra is, in a sense, used to find unknowns, things that we just don't know about. So we are going to correlate that to matrices. So take a peek here. We really only have two examples for you today before you guys try some of your delta math. First example is a little more mild, and then we go to a bit of a spicy one. So the example looks like this. It gives us a matrix equation. Matrix X plus matrix A equals -1/2 times matrix B. And what it wants us to do is it wants us to solve for matrix X in this equation. Okay, it defines the two matrices, so this is good that we talk about the order of these. This is a 2 by 2, and the same with the other one. This is a 2 by 2. That's a good thing because then we can do some matrix addition. Would not be good if these orders were not the same, and it would not allow us to do that. So I'm going to show you how we go about this. I'm going to use my little whiteboard for this. So on my whiteboard, I have the two matrices, A and B, right here. And first, I just want to focus on this equation first here. So to solve an equation like this, if these were variables and not matrices, one thing we'd want to do is we want to try to isolate the variable. The variable is X. So I want to get rid of this plus matrix A. And I can do that by subtracting A from both sides. When that happens, I get matrix X equals this matrix, a little bit of a reflection in that. Let's move that down a little bit. Okay, sorry about that. Minus matrix A. So this is the idea, is that matrix X is going to be equal to the subtraction of those two matrices. But before you do the subtraction, I want to make sure I do this scalar first. All right, so let's take a peek at that. Off to the side here, here's matrix B. And I'm going to do is I'm going to write matrix B again. I'm going to put this scalar of -1/2 out in front of it. And then I'm going to subtract, after I do that, matrix A. And I want to make sure I do it in that order. Order is important for matrices, addition and subtraction. So here we go. First thing I want to do is I'm going to basically multiply all the elements in this matrix by -1/2. So I'll basically take half of them and change them to opposites. So I'll do that. So half of 0, half of -6 is -3. You change it to its opposite. And now I can just subtract each of these elements. So make sure you just subtract the elements from the same addresses. So those two, -2, -9. That's going to be -11. Let's go put my answer off to the side here. -11, and then 1 minus a -3. All right, so that's actually 4. 1 minus a -3. Be careful there. 0 minus 12. And then 3 minus 0. There we go. Okay, so we're using this idea on how we solve an equation algebraically. We write it out. Once we write it out, then we simplify using those two defined matrices. So let's just kind of switch gears a little bit here. Let's take a look at one more, just one that's a little bit spicier. Okay, so here we go. I'm going to define A and B. I'm going to ask then that we do a little bit of solving, and we find matrix X. All right, so matrix X is here. Before I get anything done here, what I want to do is I want to just do a little algebra here. If I want to isolate this thing, I want to get rid of this first. And so I can move that basically over to the other side of the equation by subtracting that matrix from both sides. Just make sure we preserve that order here. Okay, so that's going to be minus 3 times matrix X equals the opposite of matrix B minus 1/2 matrix A. Now before I try to go and divide by this, we want to be careful of it because these aren't just variables. These are variables that stand for a matrix. So I can use some of my properties from Algebra 1 and 2, but I want to be careful a little bit, and I'll show you what I mean by that at the end. So first thing I want you guys to do is just simplify this part. So we're going to take the opposite of matrix B. Here's matrix B over here. I'm pointing to it. So I just want to change each one of these terms to their opposite. So 6, -2, -1, +4. That's the opposite of matrix B minus 1/2 times A. So minus, let's go 1/2 times matrix A. So matrix A is up here. So let's just do 1/2 times each of these elements. 1/2 times 0 is 0. 1/2 times -4 is -2. 1/2 times 10 is 5. And 1/2 times 2 is 1. Okay, so now we have this. We're going to subtract. We're going to simplify before we take care of this -3 out in front here. So we'll simplify this a little bit here. 6 minus 0, that's 6, -2, minus a -2. So plus, that's 0. Then -1 minus 5, that's -6. 4 minus 1 is 3. Okay, so that's equal to -3 times matrix X. Now, if this was an equation and this wasn't a matrix, I'd just divide both sides by -3, but it's not. So instead, what I'm going to do is I'm going to multiply both sides by the inverse of this. So the inverse of this is -1/3. Multiply both sides by the inverse of that. -1/3 times -3 times matrix X. These cancel. So this is going to be just matrix X. And then here I just take this as a scalar. -1/3 times each of these elements. So 1/3 of 6 is 2. And it's a minus. 1/3 of 0 is 0. 1/3 of -6 is +2. And 1/3 of 3 is 1. And it's a minus, so it's a -1. So we need to be a little bit careful here. We don't divide matrices. We can only multiply matrices. So when we do this, when we have something like this, make sure we multiply by the inverse of this. And that's it. A couple pieces for you guys to practice today. Hope you're doing well. Until next time, you guys stay clean, wash your hands, disinfect your phones, and most importantly, be kind.